Hi, welcome to section 6.9. This is the final section of Unit 6. There's nothing really new today. We know how to do most of what's going on. We just need to apply a lot of different ideas that we've been working on and putting them all together. And we're also going to be going back to our good old friends, domain, range, and asymptotes. So just as a quick reminder, we had this cool function f of x, and then we created the reciprocal function, which was a flip of f of x. But you notice that it really freaks out. So this is f of x, and there is our reciprocal function. We really were trying to avoid this spot right here, where we were dividing by 0. We can't do that. And it makes the graph f of x really just flip out. And that's why we get such a bizarre shape with the graph of f of x. We also never are able to get it to spit out 0, because you can't do 1 divided by something in order to get it to spit out 0. So we get yet another problem. We have problems with the domain. We have problems with range based on just like how fractions work, which causes us some trouble. Now, we do have some new reciprocals, the new trig functions. So their graphs are going to freak out slightly as well. Now, they freak out in a sense. Now, there's a lot going on this page. But in other senses, they behave the way much more than the relationship between x and the reciprocal function. It's following a very similar pattern of sine. So here's my sine graph. Secant's graph just bounces off of the tops and off of the bottoms of each part of our sine function. Since sine repeats, cosecant also repeats. So all of these parabolas just kind of get flipped upside down. Now it also does freak out just like x and 1 over x does whenever sine touches the x-axis, because at these points right here, we're doing 1 over, say, sine of pi is 0. 1 divided by 0, we can't do that. So cosecant freaks out at these points, and we get all of these vertical asymptotes. And we can represent them like this, as x equals plus or minus n pi. So all those asymptotes are where we can't do cosecant. At pi, we can't do it. At 2 pi, we can't do that. At 3 pi, we can't do that. At 4 pi, we can't do that. So this n is just representing some natural number. So 1, 2, 3, 4, 5, 6, 7. And we have a plus or minus because we can do the same in the negative direction. -1, -2, -3. Now our domain is just everything, but don't be on the asymptotes. Hey, remember, don't be on the asymptotes. So our domain is just whatever our asymptotes are not. So it's all real numbers except our asymptotes. Our range is this middle area. We're not able to get sine's values back out because we need to kind of run away from them. So our range is limited in that it cannot be where sine actually equals. And actually, I just noticed this. These should be brackets, and everything crashed. Good thing I saved before I started. And we're back. These should be brackets, not parentheses, because we can be right there at the tops. So they do meet at that spot, because when we flip it, it doesn't do anything. So it does meet right there. Now, secant and cosine follow a similar pattern. I don't think it's worth drawing all that again. Actually, yeah, no, it is worth it, because a cosine has a little bit more trouble. Sine, it was pretty obvious. It was pi, 2 pi, 3 pi. But cosine, it's not, it's kind of these in-between spots. So how do we represent it? Well, to represent those asymptotes, you pick one as your first. So whatever one you want to be your first asymptote, you just pick that one, and that's your first asymptote. You can do this one, you can do this one, you can do this one. It don't matter. You just got to pick one. So I'm going to pick pi over 2. So that's my first asymptote. So you pick one to be your first. And then you say, how far do you have to go to get to the next one? Well, we gotta go 2 tick marks. And it seems like if we check this gap, that's also 2 tick marks. So we've got to move over a pi, and then pi again, and then 3 pi's, and then 4 pi's. So then just, what's your first one? And how far do you have to go to get to your next one? And you're going to do that a whole bunch of times. Again, these should be brackets. And yeah, we're set. So let's do some examples of these. So I've skipped the part of us figuring out all the transformations and drawing all that stuff, and I've just drawn what, if this was cosine, just drew that. So in order to make our secant graph, it's really, really easy. All you have to do is you just got a little extra steps at the end. First, you draw your vertical asymptotes wherever we touch the x-axis. So, whoop, 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 whoop. So these are all of my vertical asymptotes. Those are my bad places. Then you just bounce off the tops, boink, boink, and then you bounce off the bottoms, boink, and boink. Okay, now we want to list our domain, range, and asymptotes. I always start with my asymptote. Pick your first one. Can be whatever, just got to pick your first one. I choose you. That x equals, let's see, where's that going to be? It's halfway between 0 and pi over 3. Oh, that's easy, pi over 6. Plus or minus n, because we're going to add in a bunch of stuff. How far do we have to go from here to there? Well, it's 2 tick marks, and 2 tick marks seem to be pi over 3. There we go. That easy. Where's your first one? How far do you have to go to get to the next one? Our domain is just whatever the asymptotes are. It's everything but our asymptotes. So domain is all real numbers except our asymptotes. And what are our asymptotes? I just freaking wrote it. Pi over 6 plus or minus n pi over 3. Easy. Range, also easy. Range is our y value. So how low do we go? We're always going to be heading towards negative infinity on these things, but how low, where's our first kind of like stop point? Because there's a gap. These only go up to -4. So we keep going la-li-da-di-da up to -4. Then there's a big old gap where that green line is wobbling between. We don't pick up again until 4. So we pick up again at 4, and we continue on towards infinity, because you can see those things go up and up and up and up for forever. It's that simple. Let's try this one. So we want to find our vertical asymptotes everywhere it touches the sinusoidal axis. While it might be the x-axis, remember, like that +3 happened afterwards, after we evaluated cosine. So that, even though we're adding 3 later, and it seems to be, yeah, it's spitting out 3, well, that's still where it's breaking. So that is where we're going to have our vertical asymptotes, everywhere we touch the sinusoidal axis, because that is where cosine is going to break. Then bounce off the bottoms, bounce off the tops. Boink, boink, boink. That's it. Graph made. Okay, cool. Next, asymptotes. They're at wherever x equals. So what's your first one? Be whatever you want. I choose this one. That's the one I pick. You could also pick this one. It doesn't matter. Just pick one. Pick one to be your first asymptote and write it down. So let's see. It's halfway between 0 and pi over 2. Well, pick pi over 4. Plus or minus n. How far do I have to go to get to my next one? Well, it seems to be 2 tick marks. And if I check right here, 2 tick marks seems to be pi over 2. Cool. Pi over 2. First one, and then how far do you have to go? What's our domain? So our domain is all real numbers except the asymptotes. Except pi over 4 plus or minus n pi over 2. And remember that n pi over 2 is just like I need to add pi over 2 over and over and over and over and over and over and over again. What is our range? Well, it goes all the way down to negative infinity. Look at them arrows going down. How high does this thing go? It seems to stop right about there. So that's at 2. Oh, bracket. And then when does it pick up again? Well, it picks up again up here, which seemed to be at 4. And then goes and goes and goes to positive infinity. And that's it. That's all you do these things. Yeah. So just remember, so wherever you touch your sinusoidal axis, that is where it breaks. So pick one to be your first, and then go plus or minus n. How far do you get to the next one? Then the plus or minus n will get to your next one, and next one, and next one, and we'll even go backwards. Your domain is all real numbers except for your asymptotes. And then your range, see what's going on in terms of y values. Where is that gap? That's it. Thanks for watching. Bye-bye.